Okay, guys, so we have experiment number 3 here, which is about the reaction of metals with the strong acids and bases. To start off with metals, and most of this information we have already done in our lectures. So metals are solid and shiny elements that have got certain properties which are common in them, and those properties are high electrical and thermal conductivity and high malleability as well. So they can conduct heat and electricity, and high malleability means that we can change their shape by applying pressure on them. That's why we can make ornaments or jewelry from gold and silver, which are elements. We can modify their shape basically. These metals are located in groups 1 to 15 in the periodic table. Two main types or categories are there, the representative metals and the transition metals. So representative metals are group 1, 2 and 13 and to 16, whereas the transition metals are in between these representative metals in the periodic table from group 3 to 12. And by definition, metals easily lose one or more electrons. That's their definition from their valence or what we call the outermost shell. And after losing the electrons, they will form a positive ion. So they can lose one or more electron. If they lose one electron, it will be +1, +2, and +3, and so on. And most of them are considered as reactive elements. They are very reactive in nature, like to react with other molecules or atoms. So here we have a colorful periodic table, basically classifying the metals and non-metals plus different types of metals as well. So in the previous slide we saw from this group 3 to 12 are the transition metals. Basically we can see at the bottom the classification. The yellow ones are the transition metals, and group 1 and 2, as well as from 13 to 16, 16 which has only got one LV. But these groups contain the representative metals, and these representative metals also have different classifications. Some the group 1 are called alkali metals, then we have alkaline metals, 13 have 14 as well have got some basic metals, and on the right side and at the bottom are basically different elements. The non-metals are there on the right top side of the periodic table. Next up are acids and bases, guys. Again, a repetition from the lecture, so it's a kind of a review what we already learned in the lectures. So the most basic definition of acids and bases according to Arrhenius was that acids are substances that generate the protons or H positive ions in the solution when they are dissolved in water. An example is HCl. When we put it in water, it will generate or produce protons. Bases, on the other hand, according to Arrhenius, are the substances that generate the hydroxyl ions or OH negative ions when they are dissolved in water, and NaOH is an example. So acids and bases can also be classified. The two main categories of these acids and bases are strong acids and bases and weak acids and bases, and we discussed them. If acid or a base is completely ionized in water, we call it strong acid. If its ionization is less than 100%, we call it a weak acid or weak base. So these metals have got a tendency to react with the acids and bases, and based on their reactivity with acids and bases, we can classify these metals into three other categories as well. Most of the metals, as we know it, reacts with acids or bases. So they will either react with the acid or base. The general reactions are shown with the acid. With any acid, when this metal reacts, it will produce M, a positive ion, and hydrogen gas. Whereas with the base, when it is reacted, it will give us the MOH, and again the hydrogen gas will be produced. So there are two main categories where we can say a metal which can react with both acids and bases. Such a metal will be called amphoteric metals. Do remember, most of the metals react with either acid or base, but some of the metals can react with both of them, so they will be called amphoteric metals. And the last category, a few metals which does not react with either acid or base, with none of them, is called inert metal, or another name for this is unreactive metal. These are three types of metals, you can say, based on their reactivity with the acids and the bases. So the practical is mainly about the reactivity of the metals with these acids and bases, as we saw in the previous slides. So we will investigate basically and observe the chemical reactions that these metals will have with the acids or the bases. And if a metal does not react, like unreactive or inert metal, and the example is gold. This one, gold, is a unreactive metal because it does not react with hydrochloric acid or sodium hydroxide. So neither reacts with the acid nor a base. So during the reaction, how are we supposed to know that the reaction has occurred between the metal and the acid? So we saw previously as well that an important product is the hydrogen gas. And whenever a gas is produced in a reaction, it will cause bubbles. These metals, when they will react with acid or base, will produce the hydrogen gas, and this will cause bubbling in the solution. And more reactive the metal is, faster will be the rate of the bubbling, so it will be more severe and more faster. So these reactive metals which react with acid or base can react with either acid like HCl or base sodium hydroxide to form a metal chloride or metal hydroxide. So one of these will be the product, metal chloride or metal hydroxide, depending upon whether it reacted with HCl or NaOH. Plus what will always be there as a product is the hydrogen gas, which will produce bubbling and tell us the or you can say confirm us for the reaction occurring. So here we have the reactions that was told in the previous slide. When metal reacts with HCl, metal chloride is produced, hydrogen gas and bubbling will be there. When it reacts with a base, the typical base sodium hydroxide, metal hydroxide will be the product, hydrogen gas and bubbles will be there again. So bubbling will tell us that the reaction has occurred. And at the bottom we have got a chart of these metals from bottom going to the top is showing the increase in reactivity. So gold at the bottom does not react, so its reactivity is minimal, whereas potassium has a very high reactivity with these acids and bases. So the main purpose or the objective of this experiment is to investigate these reactions between the strong acid and base with the metals, and we will try to find out the reaction changes, monitor the rate of the gas bubbling, because that is going to tell us how much reactive the metal is, and we can easily distinguish between a reactive and unreactive metals. Like the noble metals or inert metals, as we call them, because there will be no reaction in the case of inert or unreactive metals. The materials mainly required is a strong acid, which in this case is 1 molar HCl. A strong base is also needed, sodium hydroxide 1 molar is used. Test tubes will be needed for putting the chemicals in, and small pieces of some of the elements or the metals, which we are going to use, like copper, aluminium, zinc, magnesium. Any metal that we can easily find can be tested in this reaction. So the procedure of the reaction, guys, we follow these steps. Basically, we take 4 test tubes and add 2 milliliter of the HCl or the hydrochloric acid. 1 molar means it's a very strong acid in all of the 4 test tubes. Then add up the 4 metals that we have, small pieces of zinc, aluminium, magnesium, and copper to each of the 4 tubes. Begin the time of the reaction. So we need a stopwatch to check the timing as soon as the metal is added. So, means we need to know how long it takes for the bubbling to start. So we will record the visual observation like presence and rate of bubbling, whether bubbling is there, how fast it started, and how severe it is. And then we repeat the same thing with four other test tubes, this time putting in the 1 molar sodium hydroxide base in them, and similarly adding the metals to it and find out how long it took for the bubbles to come, or what is the rate of the bubbling. So we have a chart here, rate of bubbling with HCl and with NaOH. Simply we record the time, how long it took for the bubbling to start, and at the end we can simply write if bubbling occurred, it means it's a reactive metal, and if no bubbling happened after some time, it will be called unreactive metal. So the four metals that were used in the practical, aluminium, zinc, and magnesium. These are the ones that reacted with the acid or the strong acid that we put in the test tube. So these are all three are reactive metals: magnesium, zinc, and aluminium. Whereas copper is a unreactive or inert metal because no reaction happened with the acid nor with the base. Even when we added the base, copper will not react, so it's a inert metal. Whereas aluminium, zinc, and magnesium reacted with the base as well. So they react with both acids and bases, so they can be classified as amphoteric metal. Sorry. There need to be a correction here at the top. It should be aluminium, zinc, and magnesium that reacted or represented by the Mg. Copper did not react with the uh, with the uh, with the acid or nor with the base. So copper has no reaction. It is the inert metal. So make the correction in this one, guys, please, on both with the reaction with acids as well as with the bases.